Welcome to Data and Features in Machine Learning, part of the Fundamentals of Machine Learning course for aspiring AI practitioners. In this lesson, we'll explore how data underpins machine learning models, the concept of features, and why data preparation is crucial. Think of data as the raw material and features as the refined elements that help a model learn patterns. You'll discover how to gather, clean, and organize data. Data in machine learning refers to the collection of examples or observations used to train and test models. It can be numerical, categorical, text-based, or even images. Essentially, any real-world representation you want a machine to learn from. Each data point holds various attributes, like a product's price, color, or category. These attributes become the building blocks that teach your model patterns. Ensuring your data is relevant, representative, and accurate is crucial, since the model can't learn beyond the scope of what you provide. The quality and diversity of your data often determine the success or failure of a machine learning project. Garbage in, garbage out. If your data is messy or incomplete, no fancy algorithm can magically fix it. On the other hand, well-curated data allows your model to uncover insights and make reliable predictions. Picture a detective assembling clues to solve a case. Each clue is a piece of data, and the more relevant clues you collect, the easier it becomes to solve the mystery. Imagine a small online retail store that wants to predict weekly demand for various products. Initially, the owners guess which items will sell, often running out of popular products or overstocking slow-moving ones. By leveraging sales records, customer demographics, and even weather data, they build a clear picture of purchasing trends. This raw data becomes the foundation for a predictive model. Soon, they're stocking items more efficiently, reducing waste, and boosting profits, all thanks to a well-collected, properly understood data set. Features are individual, measurable properties or characteristics in your data. Think of them as columns in a spreadsheet, like age, height, or monthly expenditure. These features feed into your model, helping it recognize patterns that lead to accurate predictions or classifications. For instance, in a housing price data set, features might include the number of bedrooms, square footage, and neighborhood. By carefully selecting which features matter most, you optimize your model's ability to learn and generalize from the data provided. Feature engineering is the art of transforming raw attributes into meaningful variables that better capture underlying patterns. For example, if your data includes a date of purchase, you could create new features like day of week or month to reveal seasonal trends. This process might also involve normalizing or scaling values, combining multiple features into one, or turning text into numeric forms. Feature engineering can drastically improve a model's performance by making hidden insights more explicit, ensuring your data tells the full story. One common approach to understanding how each feature impacts a model is a feature importance chart. Picture a bar graph where each bar represents a feature, and the length indicates its influence on the model's predictions. This visual quickly reveals which features drive outcomes the most. For instance, you might find square footage is more significant than number of floors in predicting house prices. By focusing on the top features, data scientists can refine or gather more detailed data around those key areas. Before you feed data into a model, you must clean and organize it, removing duplicates, handling missing values, and correcting inconsistencies. This step is like preparing fresh ingredients before cooking. If you skip it, your final dish could be spoiled. In machine learning terms, a messy dataset introduces noise that confuses the algorithm. Proper data preparation also includes splitting data into training, validation, and test sets, ensuring a fair evaluation of your model's performance later on. Consider a hospital aiming to predict patient readmissions. They collect patient demographics, medical histories, lab results, and treatment outcomes. Initially, the data is scattered across multiple platforms with incomplete records. After merging, cleaning, and identifying meaningful features, such as lab test results or length of hospital stay, doctors gain a powerful tool. The model forecasts which patients need more attentive follow-ups, improving care and saving costs. This case study highlights the real-world impact of clean, well-engineered data. Sometimes data scientists encounter incomplete or skewed data. For instance, an online service might mainly capture urban users, leaving rural populations underrepresented, leading to biased predictions. A creative solution often involves seeking additional sources, surveys, public databases, or domain-specific research. Think of it as adding missing puzzle pieces to see the full picture. While it takes extra effort to fill data gaps or correct imbalances, the payoff is more accurate, equitable models that serve a wider audience. If you're looking for publicly available datasets to practice your skills, websites like Kaggle and the UCI Machine Learning Repository are treasure troves. You'll find data on everything from housing prices to healthcare metrics and even wine quality. Browsing through sample datasets can spark new project ideas and teach you how to handle real-world data irregularities. Always be mindful of licensing and ethics considerations and respect privacy guidelines when using open-source data. Visualizing data distribution is crucial before deciding which features to include. A simple histogram or box plot might show whether a feature is skewed or if there are unexpected outliers. For instance, in a sales dataset, if most purchase amounts cluster around $20, but some are in the thousands, you have an uneven distribution. Spotting these patterns early helps you decide if certain transformations, like taking a logarithm, can improve your model's stability and performance. Feature selection involves choosing the most relevant variables for your model. You can use methods like correlation analysis, mutual information, or specialized algorithms, like Lasso, to highlight important features. This not only simplifies your dataset, but often improves model accuracy and speed. Think of it like pruning a garden. Removing unhelpful features lets critical ones flourish. This step is particularly vital for large, complex datasets, ensuring you aren't overwhelmed by irrelevant information. Throughout this lesson, you've learned the fundamental role that data plays in any machine learning project. You explored the concept of features as the pillars that guide a model's learning process. We dove into data preparation, cleaning, organizing, and splitting your dataset, and discussed how feature engineering and selection can shape your model's performance. We also explored real-world scenarios, from retail to healthcare, that underline why these steps are crucial. Quality data and well-crafted features lead to powerful, transformative solutions, whether predicting hospital readmissions, optimizing retail inventory, or personalizing user experiences. By knowing how to select and engineer features, you minimize guesswork and produce models that genuinely understand the domain. This foundation directly impacts real-world outcomes, saving time, money, and even lives. Equipped with these insights, you're ready to dive deeper into modeling techniques, confident that your data is both accurate and meaningful. Congratulations, and see you in the next lesson.